Hello, good evening, friends. Welcome to Unacademy, which is the largest online education platform for GATE, computer science, and information technology. Here, myself, Malishim Devasane. Today, I'm going to talk about the dynamic memory allocation. And here, we are going to see the four functions: the Malloc memory allocation, and Calloc, and Realloc, and free. These are the four functions which are very popular for memory allocation and deallocation. So let's start this session with an introduction to my background as well as the plus benefits. And myself, that is, I have secured GATE rank 119 and 210 in my BTech with self-preparation. Then I have completed MTech from IIT Bombay. Here I have 12 years of teaching experience in GATE classes, and now here I am going to take DOC compiler programming on this channel. This is my referral code. If you are interested to take the subscription any point of time, choose DEVALIVE to get 10% discount. Additionally, you will get the guidance. That's the most important one to crack the exam. So these are the classes that I conduct on Unacademy special classes. You can follow my classes, you can follow my profile to get the concepts. And these are the courses that we take on Plus: complete practice courses, revision courses, crash courses, doubt clearing courses, and test series. And all these courses from every educator is going to be available on Unacademy. So for a single subject, you will have a lot of opportunities to learn, from the basics to the interpretation level that is required to application knowledge. So that are the benefits of the Plus, and that all are, we are having live classes, and you may have the crash courses, as I said, weekly test and doubt solving sessions as well as courses, and you will have the classes in both English and Hindi, and rank improvement batches, revision courses, and so on. Plus so many benefits and iconic all the benefits of the Plus. Additionally, you will have assigned with guide, and you will have a study plan, you will have study booster sessions, and you will have a personalized test analysis, you will have separate study material. So these are the benefits you will be having in iconic subscription. And you can see that the 1 year, 1.5, 2 year plans are very popular for Plus subscription. You can see the total amount after applying DEVALIVE code for 1 year, 1.5 year, 2 years. Similarly, you have iconic two popular plans like 1 year and 2 year, and that is 45,225 for 1 year after applying DEVALIVE code, and 66,600 for 2 years iconic subscription. Yeah, Abhishek, good evening. Vishnu, good evening. Yeah. Piyush, good evening. And Chakraborty, good evening. Yeah, good evening everyone, good evening. And guys, show me your presence. You know that. Please like the session. If anybody forgot to like the session, please do that quickly. Yeah. I'm waiting for your likes. This is our Facebook group, GATE Aspirants. You may join. And this is our Telegram channel from Unacademy GATE CS. Subscribe to this channel, you will get a lot of updates daily. And we have so many YouTube channels which are completely free, which are from Unacademy, and these are going to benefit engineering students. Please share these channels with your friends. And on this channel, we have all the subjects for the GATE exam and semester exam, and also placement preparation. So you can share this channel to your friends. And guys, as I said, please like the session and share if you have any friend, and subscribe. Today, yeah, good evening Akash. Good. Yeah, thank you so much. Let's begin today's session. In the previous sessions, we have seen recursion, and we will have much practice. As I said, the recursion, we have practiced many questions. Still, we are going to practice in weekends, some weekends. And static scope, dynamic scope, we have practiced in the previous session. Now we are going to see dynamic memory allocation. And what is dynamic memory allocation? If you want to allocate dynamic memory, what support or what kind of support is required in C programming? That is Malloc, Realloc, free are 4 functions. Then how to use them in C programming. So let me tell you the story of the memory allocation. Guys, everybody knows memory allocation, right? That memory allocation for data, either static or dynamic. Mainly we have 2 types of memory allocations, that is static and dynamic. If you have a data region, that is the static allocation. And that heap region, stack is different allocation, guys. That is automatic creation and deletion. Heap region is going to be dynamic. Right? Heap region, whatever the data that you allocate, we call that is dynamic data memory allocation. Yeah. Vatika, good evening. Mukherjee, good evening. Yes, good evening everyone. Good evening. So now we have mainly 2 types of memory allocation, static and dynamic. There is another one, stack region. That is stack allocation, a special memory. And we have the code. In the code, we don't have a data. Remember that. The code is only instruction to execute certain operations like addition, multiplication, subtraction, move, and so on. Yeah. Now, what is the advantage of this dynamic memory allocation? The dynamic memory allocation is mainly we are going to deal with heap region. And we know that, guys, the heap region, what is the speciality of this heap region? The size is grown as per the availability of the memory in the system. Size depends on the system. It's not fixed. Size depends on system. It can be grown as long as the memory available in the RAM. So it depends on operating system how much size is allotted for heap region, right? So this heap region size is nobody can fix how much heap region you want to use at runtime. But every time you want to allocate, you require the support of the library functions. So we have stdlib.h. This is the library file, this header file, in which there are library functions declaration available, like malloc function, declaration is available, calloc and realloc and free. These 4 main functions are going to help us to allocate and deallocate. So if you want to create any memory here, let's say I want to create 10 bytes data, 10 bytes size of heap, then this block is going to be created and its address is given to the variable which basically deals with pointers. So pointer support is required. We require pointer support. If you don't have the pointers, you cannot handle the address of this heap memory, because there is no name. There is no name except address. There is no name for this memory. In general, we have int x, int y. That is not the heap memory. That is for either stack or data region. Depends on the storage class. But we require the pointers support. Pointers to support the dynamic memory allocation. Remember that, guys. Because these pointers will hold the address so that we can deal with the data inside this heap region. Allocation and deallocation. Yeah. So this is the kind of a memory where there is no name for heap memory, but we can handle the addresses. And to support this allocation and deallocation, you require mainly this Malloc, Realloc, Calloc free functions to allocate and to free them. And basically these two functions will help us to allocate, and this one to resize the reallocation. If you want to do any increase or decrease, free to completely deallocate, to release the memory, release that memory, free completely, to make free from the heap region. So how to use these four functions? Today we are going to discuss about these four functions. Let's begin one by one. Guys, the first Malloc function. And what is Malloc? M represent a memory. So memory allocation is full form of Malloc. You can assume that. So Malloc function, what it does, it is going to allocate dynamically a single large block of memory with the specified size. What is that means? Like malloc of 10. It means 10 bytes is going to create in heap, allocated in heap, but its return type is going to be void type. You can store integer data, you can store character data, you can store float, you can store any data, you can store structures, right? So inside this heap region, you can store any kind of data inside. So return value of this Malloc, return type of Malloc, that is going to be void type. So it returns void type. You decide what kind of data you are going to handle. So you can do the typecasting as per your requirement. Typecasting. And you can typecast into a pointer of any type, address of integer, address of character, address of float, any kind of the pointer form. And when you create the data, like 10 bytes you are going to create using this Malloc function, then who is initially, it is created as a single block. Remember that it is created as a single block. 10 bytes is created as a single block. You decide how do you want to access this block. Do you want to access integer by integer, character by character? That is your decision. Your decision. And by default inside unknown value exists, garbage value. It's not going to assign any value inside. Any value inside is not going to be assigned because Malloc functionality is not to initialize anything by default. So now to understand this Malloc, we require a program how to deal with this heap memory, how to create, how to assign the address to the pointer, and then how to access the location of this heap memory. Yes, good evening Jayesh. Alright. Now let's begin one example to understand how the Malloc we can use inside the program. Now look at guys. We require stdlib library.h to access these functions, and stdio.h, printf scanf we are using regularly, so it is must. And we are starting execution guys. P, it's there in the stack. Remember that the P is there on stack region, and I also there in stack region, that is inside the activation record of main. Now P is there in the stack. There are here three memory regions required. One is code to store the code, other stack, other one is heap. But you don't require data region. The reason is we are not having any global variable, we don't have any static variable. So we are going to use stack section. Assume that we have the P and also I, initially garbage, and we have heap region. Inside them we have to do something. Right now nothing happened. When you are executing this line, P is equal to Malloc of 5 into size of int. Assume let's say size of integer size is 2 bytes. Then this is going to create 10 bytes. 5 into 2 is going to create 10 bytes memory in heap, guys, in heap. This is going to be 10 bytes. And you are dealing, and look at that, the program is for creating dynamic memory of array of 5 integers. Now at runtime, I want to create a dynamic array, but dynamic array we don't have support from the program, but from the heap region you can create like a dynamic array with 5 elements. Let's look at. Now this is going to be created as a single block. This is just a single block. We don't know, we have 5 elements or 10 elements inside, we have to decide. And we are typecasting. So P is going to store address of integer. So assume this address is, let's say, 2000. And what P assumes? It assumes it is going to hold integer address. So it is going to assume I have 2 bytes. 2 bytes. It's just going to assume. It doesn't know that 10 bytes exist. It knows that I am pointing to 2 bytes, that's all. Because it is address of an integer. You have already typecasted. Now P, either you will have an address or you will have a null, because every time malloc may not succeed. If suppose heap is full in your program, sometimes you are dealing much heap memory. After some time heap memory can be full. At that time the system will not grant you the address and it should not allow you, malloc will fail. In that case the P is going to assign as a null. Then if P is null, then you can't execute your program, because the program is no meaning, it will not have any meaning. So you will call exit 0. That means unsuccessfully we are executing this program. But if the P has some address, means memory allocated successfully, else means memory allocated successfully, that 10 bytes. Now the address of the first byte or first 2 bytes is given to the P. Now P is pointing to the first 2 bytes. But P exists on the stack and actual heap memory is there in the heap region. Everyone, dynamic memory. And now you are asking the user print, you have enter 5 elements. Then you are going to enter 5 elements. How we are going to handle? Address of P of 0. Matlab P of 0 is a 2000 and P of 1 is 2002 and P of 3 is 2003, 2004, and let's say 2006, 2008. And P of 0, address of P of 0, the first time 2000, next time 2002, next time 2004, because I value is going to increment. 2006, 2008, you are giving the address at that place, the value is going to store here. Suppose you are entering, suppose you are entering 10 space 20 space 30 space 40 50, then that is going to be stored here, because the pointer knows how to access 2 bytes. Yeah, everybody, it's not an array, it looks like an array. You are using like an array, but it is just one block. It is 10 bytes block. Remember that 10 bytes block we are using like an array. We are using like an array, so we can call it just like a dynamic array. But in C, dynamic array not supported, but we can create the dynamic memory which looks like a dynamic array with the help of the pointer. Now at this point, for I is equal 0 to 4, we can print one by one the star of 2000, that is, you are going to print first time 10, then 20, 30, 40, 50. It is going to print all of them. So output is going to be 10, 20, 30, 40, 50. So this is how we can store the data inside the heap, and we can access from the heap with the help of pointer. If you don't have a P, you can't access. If you don't have a pointer, it's impossible to access the heap memory. So here the pointer support is compulsory. Pointer support is required to support pointers are required to support dynamic memory. Pointer is required to support dynamic memory. Because P knows how to access. P knows how to access. If you want to store the string, you can do that. But at that time, char star P, you have to declare, and typecasting, you have to do char star. There are two things that you can change, int star here, int star. Both of them make it as char star so that you can string dynamically too. Everybody, that time 10 into size of char, then 10 bytes can be created. Yeah, if anybody want to store the string, how do you create, guys? You can do like this, char star P, and you can do the typecasting like P is equal to char star, means it will assume that it is returning address of the character, then Malloc, suppose I want 20 bytes, then 20, you can do that directly. So 20 bytes will be created, 20 bytes a single block, remember that. And P is there on the stack, this is on the stack, this is on the heap. And now assume this address is 2000, then it is going to hold 2000 because it creates 20 bytes and it assigns the address of the first byte. Then P indirectly it assumes it's pointing to 1 byte because P is, it assumes. Now when you increment the P, it goes to 2001. It goes like that until 2000, let's say 2000 to 2009. Everybody, 20 bytes, sorry. So it's going to be 2019. 20 bytes means 20 characters you can store. Now you can store a string inside this. String you can store now, guys. One by one you can send the character to this. It is allowed now. Everybody, you can store the string by writing a loop. Yeah, I Satyajit. So this is a very interesting dynamic memory, guys, but only one problem is in Java, when the use is over, automatically this dynamic memory is collected into the garbage collector. By the garbage collector, it will be freed automatically, but in C language you must free using the free function. We will learn slowly. Now guys, what is the difference between Malloc, Calloc? What is the difference between Malloc, Calloc? Malloc creates a block, one block which has the garbage, but Calloc will create consecutive blocks. Both are different. It is also dynamically allocates specified number of blocks. वहां पर सिंगल ब्लॉक, यहां पर नंबर ऑफ ब्लॉक्स. इसके लिए 2 पैरामीटर है, उसके लिए 1 पैरामीटर है, गाइस. Malloc is just going to take the size of data that you want, but Calloc, how many blocks you want, n represent how many blocks, and that represent each block size. That block can be assumed as element that you are dealing with. That could be structure. I want to create 10 structures. I can create here. This is going to be very useful for you because it initializes each block with the default value as a 0. It is going to keep like this. Suppose anybody writing Calloc of I want let's say 3, 6. What is the meaning of that? I am going to create not one block. I am going to create 3 blocks. Each one is a 6 bytes. Each one is a 6 bytes and initialized everybody with a 0. By default, it has a 0. Yeah. Difference between heap region and data region. Go and study storage classes. That was already completed. That what is the data region, guys? In the data region, अभी ये time है क्या? Doubt पूछना? Please watch the previous session. Data region, we don't handle dynamically. It is a static region. क्यों? यहाँ पर global data होगा and static data भी होगा. यहाँ पर static variables, global variables data. राइट यहां पर ग्लोबल स्टैटिक नहीं होता. हीप रीजन के अंदर सिर्फ Malloc, Calloc कैन हैंडल, नोबडी एल्स. Malloc, Calloc, Realloc, free. Only these functions can handle the memory of heap. This is the dynamic data. Here you can say this is the static data and this is dynamic data. What is the meaning of static data? It means the system knows before execution, and heap region that during runtime the size is automatically created, not automatically, explicitly created by the user and deleted by the user only. Heap region is handled explicitly handled by programmer, user, and these are written inside the program. You have given the instructions implicitly, you have already written the code, implicitly handled because already code exists, already informed to compiler how much size is required, but this compiler doesn't understand what is this malloc, how many bytes is going to create. The compiler doesn't understand. At runtime only it's going to be created as per your requirement. Everybody, this is the difference between heap region and data region. Clear this point, guys? Yeah. Everybody, now by default initial value is a 0. By default initial value is a 0. But when somebody talking about malloc, memory allocation, if you say 18, then 18 bytes is going to be created as a single block. This is a single block. Here this is a block. This is a separate block. There are 3 blocks here consecutively going to be created, and single block is going to be created with how many bytes? 18 bytes. आपको पता होना चाहिए इसमें 3 elements यूज करना है, 100 elements यूज करना. How to access them? It is your choice now. Right. Now एक छोटा एग्जांपल देख लेते हैं. Same program. I want to handle the 5 integer elements dynamically. तो कैसे क्रिएट करेंगे guys? P ये स्टैक में रहेगा, I स्टैक में रहेगा, और this is going to be your key. What is the meaning of that? In heap region you are going to create 5 blocks, and इसकी address, let's say 1000. This is a heap region, and this 1000 will be stored in P because you are typecasting as an integer address. The P is going to point to 1000, and next one, if you assume 2 bytes, 102468, because you already decided size of int. I'm assuming size of int 2 bytes. So 5 into 2, 10 bytes created, but 2 bytes block initially by default 0. But in malloc, you will create as 10 bytes, 5 into size of int. आपको same feel आना चाहिए. तो malloc of 5 multiply with size of int. This is how you create for malloc. यहाँ पर सिर्फ 1 parameter होगा. We will have only 1 parameter. You must mention size of data, whole heap allocation. Is that clear? Complete block size. That is the difference between malloc and calloc. Calloc कैसे create करेंगे? P is equal to calloc of 5 size of int. This will create 1 block. This will create 5 blocks. But जो 1 block है garbage रहेगा. 5 blocks है 5 initialized, 5 values are initialized, 5 elements are assigned with, 5 blocks are assigned with 0. Yeah. Clear this point? Yeah. Now, if suppose calloc is not success, that means maybe you are using the heap memory for long time. तो पाइल करके हो गया, वो अभी पूरा फुल हो गया heap memory, सिस्टम के अंदर और स्पेस नहीं बचा, तब operating system will not grant you, that is insufficient resources. Then the return value of calloc is null. So return value of malloc is not null, means successfully created. Guys, the malloc and calloc, remember that, and realloc, these functions basically returns either null or not null, returns null or returns some address other than null, some address other than null, other than 0, that is the meaning, other than null. It means returns null means failed to create the heap memory. Return some address other than null means successfully created heap memory. Successfully created heap memory. So return value बताएगा is that malloc, cloc, realloc is successfully created or not. Yeah, exactly. अभिषेक, अरे एक सिर्फ वन एग्जाम्पल है malloc क्रिएट्स वन ब्लॉक. आप डिसाइड करो कैसे यूज करना. ये क्रिएट्स कंसेक्यूटिव ब्लॉक्स, वन आफ्टर अदर. दोनों में डिफरेंस है ना. वहां आपको 5 एलिमेंट्स चाहिए तो आपको 5 इंटू 2 10 बाइट्स क्रिएट करना. यहां पर CLOC में 5 एलिमेंट चाहिए, 5 ब्लॉक्स क्रिएट करो. दोनों में डिफरेंस होता. 5 ब्लॉक्स where each block has 2 bytes. ये 5 इंटू 2 10 बाइट्स होगा ओवरऑल. मतलब 5 ब्लॉक्स हैं. यहां पर इफ यू वांट टू सपोर्ट 5 एलिमेंट्स जस्ट क्रिएट 10 बाइट्स. नहीं बता सकते ब्लॉक्स. पॉइंटर विल हैंडल, इंटीजर पॉइंटर यूज करो तो इट कैन हैंडल द 5 इंटीजर्स. इज इट क्लियर? It can handle 5 integers automatically inside the malloc, but by default malloc has the garbage value, and by default CLOC will keep 0 as default initialization. All right. Now you have the 5 blocks, whereas you see this program, you see this previous program. Where is that? This one, guys. It was actually one block. That was P able to access 2 bytes and so on, 2 bytes and so on. ये सिस्टम को समझ नहीं आता, इसमें 5 एलिमेंट्स नहीं है, आपको हैंडल करना पड़ता. एंड इसमें CLOC में इस सिस्टम को समझ में आता है. आई एम गोइंग टू क्रिएट 5 ब्लॉक्स. नाउ यू आर यूजिंग द इंटीजर पॉइंटर, सो address of P of 0 means 1000, then 1002, 1004. आप 5 एलिमेंट्स एंट्री करो. 10, 20, 30 और 40, 50. ऑलरेडी 0 था, अब 10 जाएगा इसके अंदर. 820 और 30, 40 and 50. Now same, you are going to access element by element. P of 5 will give print 10, then 20, 30, 40, 50. Same effect is same. वहां पर एक ब्लॉक बना, यहां पर 5 ब्लॉक्स बना. वह एक ब्लॉक ऑफ 5 इंटीजर साइज, यहां पर हर ब्लॉक 1 इंटीजर साइज. इज दैट क्लियर? तो दैट इज द मेन डिफरेंस ऑफ malloc and CLOC. Yeah, typecasting is very important. No error. malloc you can decide your choice. malloc you can create 100 also, doesn't matter. You can typecast to integer. You no need to typecast while accessing. You can do that. You can also say this one, it's just a warning. This is also right, but clearly आप बता रहा है integer address. यहाँ नहीं बता रहा है when you accessing the P, it just creates a warning but no error. This is absolutely all right. Okay with this code, no problem at all. Both are all right, no error at all. But it is a void return type, so while accessing the P you can decide is it integer or character address. There's no problem, both codes will work absolutely all right. Everybody, both are all right. Okay, now let's move to realloc function, guys. And you know the differences, as I said, malloc CLOc creates malloc of, let's say 10, it creates 10 bytes. जो P को असाइन कर लिया 10 bytes, आपको 5 एलिमेंट्स यूज करना है, 10 एलिमेंट्स यूज करना है, यू डिसाइड इट। यहां पर 10 कैरेक्टर्स भी यूज कर सकते हैं। अगर इंटीजर का साइज 2 बाइट्स है देन यू कैन यूज 5 एलिमेंट्स इनसाइड अ ब्लॉक। इट्स अ सिंगल ब्लॉक विथ ए गार्बेज वैल्यू। ये पहली वाली कॉन्सेप्ट है। सेकंड, P is equal to CLOC. Typecasting is your choice. You can also do the typecasting later on. CLOC, मुझे assume that 5 integers create करना, तो 5 comma size of int 2 bytes. Size of int, तो assume it is a 2 bytes. Assume that was my assumption. तो यहां पर क्या होगा, 5 blocks create होगा ऐसे. This is the one block, single block. ऐसे 5 blocks create होगा. Total 5 blocks. Each block is the 2 bytes. Each block is 2 bytes. This represent number of blocks. This represent size of the block. It just looks like exactly an array. But आप डिसाइड करोगे ये इसको कैसे एक्सेस करना, right? Yeah. And here by default 0 रहेगा. Here by default garbage रहेगा. दोनों के लिए इंटीजर पॉइंटर है तो इफेक्ट तो सेम होंगे, देन इफेक्ट तो सेम होंगे. ऑलराइट, नाउ वी हैव अ Realloc. सपोज गाइस यहां तो 5 इंटीजर्स अज्यूम किया, मुझे अभी 10 इंटीजर चाहिए तो साइज तो बढ़ाना पड़ेगा. अभी 5 इंटीजर अज्यूम किया, बाद में 2 इंटीजर ही चाहिए तो साइज तो कम करना पड़ेगा. सो दिस इज गोइंग टू हेल्प यू. Realloc function is going to help you. Either you can increase or decrease the size of the heap. Realloc function can dynamically changes the memory allocation. Either you can increase size or you can decrease the size. How do you do that? We are going to learn. It can be used dynamically reallocate a memory which was previously allocated by Malloc or CLOC. You can use this Realloc function, right? So when we reallocate, what happens to the previous data? It is going to keep existing data if you are increasing the size, and the new additionally size create करेगा, it will be maintained default garbage value. Default it will assume as a garbage. Suppose assume that you have created a malloc of, let's say 5 into size of int. तो कितना साइज क्रिएट होगा गाइस? assume that you are assigning to p. कितना साइज क्रिएट होगा? assume that 10 bytes. assume that is created 10 bytes. बट इसकी एड्रेस p के अंदर रहेगा, p के अंदर. now how to use the Realloc? This is the syntax. You need to pass the first address of the beginning of block, address of the heap. वो पॉइंटर में रहेगा ना, सो इसलिए वहां पर पॉइंटर देंगे हम. ptr और p both are assume same. ptr तो Realloc p कामा साइज बढ़ाना है कम करना, that you decide it. तो पहले 5 into size of int, अभी आपको 10 चाहिए तो 10 into size of int. तो पूरा साइज अभी पहले 5 एलिमेंट्स के लिए, अभी 10 एलिमेंट्स के लिए रहेगा साइज. तो पहले 10 बाइट्स होगा तो अभी 10 into 2 20 बाइट्स होंगे. तो अब इसको बढ़ाएगा, उसको ऐसे रहेगा तो इट इज गोइंग टू अपडेट लाइक दिस. जो ऑलरेडी एग्जिस्टिंग डेटा तो वही रहेगा, तो इट इज गोइंग टू ऐड 10 बाइट्स टू इट. मतलब अभी तो सिंगल ब्लॉक ही है जैसे दिखता है ना, Malloc इफेक्ट जैसे. Now it is going to be assigned either to the same pointer or different pointer. It is your choice now. It is your choice now. I am assigning to the same pointer p. मतलब the address of this 20 bytes, this 20 bytes will be assigned to the same pointer. You can also assign to different pointer if you want to handle with different pointer. Is it clear how to do this Realloc function? You mention the pointer as the first parameter, that's the address of the heap, and comma how much size do you want to increase or decrease. Do you want increase or decrease? So that is your choice. Here I am going to increase. इसका increase कर रहे हैं हम. तो बिकॉज 5 इंटू साइज ऑफ इंट स्मॉलर देन 10 इंटू साइज ऑफ इंट, तो पहले 10 बाइट्स था, अभी 20 बाइट चाहिए हमको. या यस या लेट्स सी स्मॉल प्रोग्राम टू अंडरस्टैंड. यहाँ CLOC यूज कर रहा हूँ गाइस, इट्स ओके. नाउ द 5 इंटू, पहले 5 एलिमेंट्स के लिए मैं ब्लॉक्स बनाया 1 2 3 4 5. नाउ अब मुझे कितना एलिमेंट्स के लिए चाहिए, मुझे 7 एलिमेंट्स के लिए चाहिए, 7 एलिमेंट्स के लिए. तो पहले ये 0 बनेगा, राइट. तो दिस विल क्रिएट, नाउ P is pointing to this one, this is a heap memory, this is a stack, because local variable P is a local variable, auto variable. Now 5 elements एंट्री करेंगे वन बाय वन. अज्यूम कर लेना 10 20 30 40 50 एंट्री कर रहे हैं हम. तो इसके अंदर क्या जाएगा, 10 20 30 40 50. अब क्या बनेगा, यहां पर रीअलॉक, मतलब साइज को अभी रीसाइज कर रहा है. 7 इंटू साइज ऑफ इंट, पहले तो 5 इंटू साइज ऑफ इंट, अभी 7 इंटू साइज ऑफ इंट, मतलब थोड़ा एक्स्ट्रा ऐड होगा. पहले मान लो साइज ऑफ इंट 2 है, तो ये 10 बाइट्स अज्यूम कर लो, 10 बाइट्स. अब कितना बढ़ेगा, 7 इंटू 2 मतलब 14 बाइट्स, मतलब एक्स्ट्रा 4 बाइट्स ऐड होगा. एंड उसमें गार्बेज रहेगा, अभी उसमें कुछ टच नहीं करेंगे हम. तो व्हेन वी आर एक्सेसिंग दैट स्कैन, सॉरी एम्परसेंड गाइस, थोड़ा टाइपिंग मिस्टेक है, एम्परसेंड P5. नाउ यू कैन गिव द वैल्यूज लाइक 60 70 इफ यू वांट. तो 60 आ जाएगा, ये इमेजिनरली यू आर फीलिंग दैट इट इज एन एलिमेंट 70. So I is equal 5 and I is equal 6. It's going to give an entry. Everybody, so this is how you can do the resize of the existing, the heap memory. Of course, for the exam point of view, इतना जरूरत नहीं, सिर्फ आपको ये क्या करता, heap memory को create करता. And one more. I will explain that slowly, guys. After the free, I will explain. Guys, if you are keep on creating the memory, then heap can be full sometimes. Example, I am going to tell you guys. Example, suppose you are writing for loop I is equal to, ऐसे कर लेते guys, 0, I less than n, I increment, and you are using a pointer, let's say P is equal to Malloc of 100, Malloc of 100. and क्या होता guys, assume that int star P एंड यहाँ पर int i, क्या होता गाइस, फ्री बाद में पढ़ेंगे हम. क्या होता गाइस, अगर n इज इक्वल मान लो 100, n इज इक्वल नहीं 100 नहीं 10 मान लो, n इज इक्वल 10, assume that n is equal 10, int n is equal 10. what will happen guys, 0 to 9 heap region के अंदर guys, heap region के अंदर this a heap, क्या होता, पहले 100 बाइट्स क्रिएट होगा, एंड देन व्हेन i is equal 0 100 बाइट्स एंड p इसको पॉइंट करता, एंड नेक्स्ट टाइम अगेन 100 बाइट्स, p चेंज होगा अभी. एंड व्हाट इज हैपनिंग गाइस, you are going to do 100 bytes again and again 10 times, but P भी change होता रहेगा. Means what is happening guys, you are trying to lose the address of the previous heap 100 bytes. The last में क्या रहेगा, the last 10th time when you have created that 100 bytes, वो रहेगा last में वो रहेगा 100 bytes. The last time that you have created, then इसका address last हो गया, we don't have this address. The P finally points to the address of the last 100 bytes. But the previous 9 times 100 bytes was created, which was there, but nobody can use now. That is called as memory leak. Problem with this is the memory leak. Memory leak also called as lost memory. There is a chance if you don't handle this memory at runtime, there is a chance after some time If n value is 1 lakh, guys, n is a bigger number, then heap is going to be full after some time. There is a chance. Then after some time, the P is going to get the null. Then system may give a runtime error that heap is a full. Of course, it may not give, because malloc CLoc function always returns null or not null. Null if it is not successfully created, not null if it creates successfully, if it allocates. Yeah, look at that, guys. This kind of programs we should never write. What do you write? If you want to do this, you just write one thing, free of P. A good code is a free of P. क्या करेगा? 100 बाइट्स क्रिएट करेगा. यूज खत्म होने के बाद 100 बाइट्स को फ्री करो, तो क्या होगा? 100 बाइट्स क्रिएट होगा, डिलीट होगा, क्रिएट होगा, डिलीट होगा, क्रिएट होगा, डिलीट होगा, क्रिएट होगा, डिलीट होगा. So you will never lose that memory. You will never lose that memory. So free of P, after this, after some time, after use of that memory, this is the good code. Now the previous 100 bytes will be freed. Next time when you allocate, the new address comes, but before that 100 bytes is going to be deleted from your heap. So this is the good code. Free of P is going to help us no memory leak. If we don't have a free, then memory leak happens if we don't use free function, if no free function. So it is basically free is going to deallocate the memory. It releases the heap memory. It is whatever the memory allocated using malloc CLoc, it's going to be freed. And whenever use of that memory is completed, you can free it. So this is the most dangerous problem in our C programming, because we don't have the garbage collector. So the free function is the must. Free function is a must. Now I'm going to write a small program for you to understand. Look at this, guys. P is going to create, the P is going to be on the stack. On the stack, it is going to point to heap memory, that is 5 integers, that is 5 integer size, that is, let's say 5 into 10, let's say 5 into 2, 10 bytes. Assume that 10 bytes. So I'm assuming this is the 10 bytes, and you will give the values. Definitely you will give the 5 values, and then after some time what happens? You will be printing them. 10, 20, 30, 40, 50 अंदर गया, और output is definitely 10, 20, 30, 40, 50. ये होगा output. And this after use, are you going to free or not? Then this free of P, what will happen? इसमें address, let's say 1000 is there. It will be there, no problem. But यहाँ पे जो 1000 से जो भी है, this will be deleted when free function called. It is going to release that. इसके बाद if you access the P, it is called as dangling pointer. इसके बाद nobody can access print P of, something like, if you are trying to do P of 0 is equal to 10 again, then this is called as dangling pointer. Why, guys? P में 1000 तो है, when you are using the 1000, but वहां पर memory is not allocated for you. This is going to create a runtime error. Everybody, so it's a very dangerous. After freeing the memory, you can't use the same location. P has to be allocated, or P has to hold other address that was useful right now. Everybody, so this is how we use allocation and deallocation. Clear this point? And if not detailed, I think you will understand when you are dealing with heap memory on your own. आपको पता होना चाहिए, guys. Dynamically you must handle the data most of the times. Okay, so in this session we have understood 4 functions. Malloc, it has one parameter, that's the size of data, the size of the block that you want, and its typecasting is your choice. CLoc, we have number of blocks, mention करना पड़ेगा, comma, each block size. That's a function syntax. And Realloc, mention the address, that address of the heap where you want to resize, that is already there in the pointer. This is there inside some pointer. You are holding that. There is no other way to hold other than the pointers. And new size you have to mention, either small or bigger, doesn't matter. And free, you have to mention address. Free, you have to mention address. This address of heap. So this is already there inside some pointer. We are already holding that. So free of pointer use karna padega, right? And Malloc, when we create, the size of the block is going to be inside the block. The default value is garbage. Garbage data exists by default. यहाँ पर 0 is initialized for every block. For each block, and the Realloc is also previous data exists. Previous data exists if you are increasing or decreasing. If you are increasing, suppose the extra memory will have the garbage. The extra memory if you create, that will have a garbage, will be default as a garbage. And the free is going to create, guys, how the system knows I have to delete, because it is going to maintain, some table. How? At 1000, it's like address and size. This is the operating system, the table for heap table, you can say that. At 1000, I have created, let's say, 10 bytes. At 1010, I have created 50 bytes. At 1060, I have created 70 bytes. This will be maintained. When you call free of address, it knows that if you say free of 1000, it goes to this row and it is going to be deleted, and from the system also it will be added to the free pool. Yeah, this is how at runtime the heap memory can be deleted. And guys, heap memory will not have a scope. Most of the people don't know that I'm trying to help you something, guys. Void f, and let's say int star p, and p is equal to Malloc, let's say 100, and you are returning the p, and you want to access to the main. You can. यहाँ पर int star q है, then you are assigning q is equal to f of this, and after that you want to access. Guys, this Malloc 100 bytes can be visible to anybody in the world who has an address. This 100 bytes will be created and it's assigned. Let's say 1000 is the beginning. This 1000 is the address of this 100 bytes. Then p is going to hold the 1000, and you are returning 1000. So q is going to have 1000. It is going to return 1000. So now previously p was pointing, now q is pointing. It can be done. This is the beauty of the heap region. Anybody can use in any program. If anybody has an address of the heap, you can use in any program, any function, in any statement. The address exists, then you can handle that heap. Everybody, the scope is not required for heap memory. Only address you can pass to any function, any program that can use this heap memory. Everybody, even like static variables, global variables also you can do the same way. Address of the global variables, address of the static variables, you can pass to any program, any function, they can handle indirectly. Yeah. So this is today's class, guys, and I hope you have learned. And today is the last class. In this session, it is the last class for C programming. And hope you have enjoyed the C programming session, and we are going to have a lot of practice sessions in weekends. Keep attending, guys, And if you have any valuable comments that how we have completed, yeah, how you have completed this C programming course, please give your valuable feedback guys. प्लीज जरूर कमेंट कर लीजिए क्यों the whole world and every student is going to look at the video on YouTube. These are the free sessions. If you are really enjoyed, please give a one comment at below this video and below every video that you watch. This is going to help us to understand, and also share this playlist to your friends and like the video. This is going to help us lot to initiate such courses in future. Remember guys, tomorrow we have, of course this is okay, tentatively scheduled guys, you can follow this regular my schedule, and tomorrow we have the announcement surprise what we are going to do in the coming, what I am going to do, surprise announcement, that what I am going to do next, what I will be teaching next, and what we are going to plan in future. So please attend the tomorrow session. We have surprise announcement to everyone. I'm going to talk about the most important subject in GATE, and that's going to be the crash course for you guys from tomorrow. Yeah. Yes, we will do, Rimpy, we will do. Don't worry, we have much time to do. And if anybody is interested to take the plus course, we are always there to help you. We are always there to help you, because there we will have a beautiful courses. You will enjoy a lot, and Iconic is more beneficial who are in second year, third year, and you will have a guide to monitor on this channel. Please follow every class which you are enjoying. And please like the session at the end. Do not forget and share and subscribe guys. Thank you so much for attending every session, and I'm so happy that you are coming, and every time you are discussing with me, and keep continuing that. So far I have completed 2 courses. One is the TOC long term and one is the C programming short term, and in the crash course we are going to see the subject that I'm going to name on tomorrow, and we will discuss more about that subject tomorrow. Please attend tomorrow same time, that is at 9 p.m. It's half an hour discussion I will be having tomorrow. Please attend. Thank you so much. Bye bye.